Hi everyone, this is going to be a short video on your special case of factoring for when it's a difference of squares. So let's look at what that looks like. So I do have a couple examples done out for you. A difference of squares, that's always one of the ones that people think are harder than it is, and it's actually a nice little shortcut that's going to make it easier for you. So let's look at what we have going on here. So you always need to make sure that you have a subtraction sign. Okay, so the reason that that's important is, think of it, this is called a difference of squares, and a difference is subtraction. So right here next to the stars, this is the whole idea here. If you have two perfect squares that are being subtracted, this is how you can break it up. So I always like to remember a difference of squares will have different signs. Okay, so difference of squares, different signs. So the first thing we need to do is determine if it is a special case. Do you have two perfect squares and are they being subtracted? If so, you need to figure out what A and B are. Not necessarily what this whole first term is, but what was squared to give you that. So find out what A and B are. Then you're just going to insert it into your solution. So into this first step I have up here, next to the stars, that's how simple this is. So when we're looking over here at our example, you can see that our problem was 81x squared minus 36. So I needed to figure out what was squared to give me 81, and that's 9. And what was squared to give me x squared? That's x. Same over here. What was squared to give me 36? 6. So I figured out what my a and b were, and I plugged them into the form here. So 9x plus 6, 9x minus 6. Again, I always like the phrase difference of squares means different signs. So I'm going to write that out for you too. A difference of squares. And I'm going to shorthand and just draw a square there. Means different signs. And talking about that plus or minus sign. So let's do the second example down here. So if you look at 32 x to the 6th minus 72 y to the 4th. 32 and 72, they are definitely not perfect squares, right? So you might think, okay, why is this even included here? What we can think about is, can I take out any GCFs first? And that's always something you want to try to do, because when you do that, you're making your problem simpler along the way. So when I'm looking at this, I can see that I can take an 8 out of both of these terms. So I can bring an 8 to the front, and when I do that, let me zoom in, this is kind of tiny. When I do that, I'm left with a 4, x to the 6th, and 8 goes into 72 9 times. 9, y to the 4th. So because I already brought that 8 to the front, I'm going to bring it to the front of my solution. It needs to be a part of it. So when I do that, now I can figure out, okay, what was squared to give me a 4, and that's a 2. And what was squared to give me x to the 6th? Now this is where it does get a little tricky. So if you remember that when you have an exponent to an exponent, they're getting multiplied. So if you can divide that 6 by 2, you can figure out what you should have had in the first place. And then we can do the same thing with our 9. What was squared to give us 9? 3. And what was squared to give us y to the 4th? Y squared. So I already figured out my a and my b. It's going to be 2x cubed. My b is 3y squared. Hard part is over. So now we just need to use this a and b into our form here. So the first one's going to be a plus b. So we have 2x cubed plus 3y squared. And then the second one will be a minus b. So 2x cubed minus 3y squared. So always remember, difference of squares breaks up into different signs. Let's look at another example or two. Again, we have one already drawn out for you. I'll zoom in since we're working on it like that. So you can see when you're looking at 16, 4 was squared to give you 16. X was squared to give you x squared. This works. Over here, 3 was squared to give you 9. Y was squared to give you y squared. Remember, you can always check your work along the way. Square these. See if it works out to what you're supposed to. Multiply these. See if it brings you back to the beginning. If so, you did it correctly. So once you have this figured out, you know your a and your b. Plug them into our form here, a plus b a minus b. It's as simple as that. Let's do one more example together. So again, the exponents definitely don't look like a 2, but they are even. So that means that I could have squared an exponent to get here. So that means that this was an x cubed. When I square x cubed, I get x to the 6th. Now for my second term, I need to take that 36 into consideration. So 6 squared would give me 36, and z squared will give me z to the 4th. And that's what we want here. We're just rewriting. I know it looks messier, but it's going to help it be easier to work with in the end. So when we break this up, remember it's going to be a plus b. I even sometimes like to get this set up with the plus and the minus. And then I'm going to write my terms in. So my a was x cubed. And my b was 6z squared. 6z squared. So there you can see my final answer, which was for a difference of squares, and I resulted with different signs.